In this video, we'll take a look at solving systems of linear equations and look at fairly basic equations and some simple methods for solving them. The first thing to keep in mind is a couple of pictures. We are attempting to find out essentially where two lines intersect. And it is possible that, that two lines will intersect in one place, or that they might intersect in no places. Or it's also possible that we could have one line coincide with another line fully, so that they would in fact overlap and we would have an infinite number of solutions. So we'll want to keep sort of our eye out for that. And just a couple of quick examples, if we were looking for them, in this case here we could have, say, y equals x and y equals negative x, which would clearly cross right at the origin. We could have y equals x plus 1 and y equals x plus 2, which would have the same slope and yet would intersect at different places along the y-axis and therefore would just be parallel. It is also possible that we might pick two lines that appear to be somewhat different. We might have y equals x plus 1, and if we were to multiply everything by 2 and we had 2y equals 2x plus 2, we really have the same equation, even though it might look a little bit different. They have the same slope and they have the same intercept. So there's some ways that we could see that the solving a system of linear equations may give us either one solution or no solutions or an infinite number of solutions. Now let's go tackle our first example. And our first example we'll look at negative x plus y equals 1, which is a line. We've got a y here and an x there. There's no quadratic terms or anything like that. And then similarly, a second equation, 4x minus 3y equals negative 6. Now the first method to consider would be just a simple substitution. And in this case, we will solve for x or for y in one equation and substitute it into the other. So I will take equation 1 and I'll solve for y and know that y is going to be equal to x plus 1. And then I'll take 1 that I've got and I'll put it into equation 2. And so where I see y in equation 2, I can replace it with x plus 1. And I'll do that now. So I'll rewrite this as 4x minus 3 times, and we're replacing y with x plus 1. So we replace y with x plus 1 there and set this equal to negative 6. And now we're back to a slightly different question. We're just solving for a single variable. And I'll multiply this out. So we have 4x minus 3x minus 3 is equal to negative 6. And we have x minus 3 is equal to negative 6, or x is equal to negative 3. And we then take this value that we've found and we bring it back to our original equation and we substitute into equation 1 and we can solve for y. And when we do that, we'll end up with y is equal to negative 3 plus 1, or rather y is equal to negative 2. So the point of intersection of these two lines should be at x equals negative 3 and y equals negative 2, or we might put it into notation negative 3 comma negative 2. And there's the first possible way we might find the intersection point for these two lines. And another possibility is to do what's called simultaneous. And in this case, we look to add and subtract the two equations in a manner to eliminate one variable. And right now I have that I have negative x here and a positive 4x here. So one possible thing we could do would be multiply equation 1 by 4, and then we could add the equations, and that would eliminate the variable x, and we'd only be left with equations, an equation with y in it. Or we've got negative 3y and 1y, so we can multiply the top by 3 and then add, and that would eliminate the y's. So let's go ahead and do 4 times equation 1, and that will give us negative 4x plus for y equals 4, and then we still have just regular old equation 2, which is 4x minus 3y equals -6, and we will subtract the second equation. And when we do that, rather, sorry, we're going to add here. When we add these two, we lose all the x's. -4x plus 4x is 0. Then we have positive 4y minus 3y is just y. And then we have 4 minus 6 is -2. And that looks like the solution we had the first time. And then we will substitute y equals -2 into either equation 1 or equation 2. And it looks to be easiest to do in equation 1. So we'll put it in there. We have -x minus 2 equals 1. And therefore, -x equals 3, or x equals -3, which is the same equation we had the first time, which is -3 comma -2 as our solution. So we've got a couple of ways we can go about doing this, and the next thing you ought to do is practice this a little bit. So I'll go back and we'll look again at the first equation, the first one we did, and remind you in the first case we did substitution. We solved for y in this case from the first equation, and we substituted this into the second equation. This allowed us to eliminate one of the variables. We solved for x in this case and then substituted back into one of the two top equations, and I chose number 1 because it was already solved for and was quite easy to use. And we had a solution of -3, -2. And in the second possible way, we used a simultaneous solving by trying to eliminate one variable through multiplying across the entire equation to make the coefficient be the same or the opposite, and had they been the same, then we would have subtracted. This again eliminates one variable, and then when we're done, we substitute back into one of the two equations and solve for the second variable. And I hope that that gives you a little sense of how you might solve a system of linear equations.